Hello everybody, today I'm gonna tell you about one of the Python framework that is Numpy. After watching this video we will be able to know that what is Numpy and why we are using Numpy in Python language. First we have to know about the definition of Numpy. That is Numpy. Numpy stands for numerical Python. It's a Python library used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transform, and matrix. In another word, we can say that Numpy is the most useful scientific libraries in Python programming. It provides support for large multidimensional array objects and various tools to work with them. Why use Numpy? In Python, we have lists that survive the purpose of arrays, but they are slow to process. So Numpy aims is to provide an array object that is about 50 times faster than traditional Python list. The array object in Numpy is called int array. It provides a lot of supporting functions that make working with int array very easy. Arrays are very frequently used in data science where speed and resource are very important. What is the Numpy library in Python? As we mentioned before, that Numpy stands for numerical Python, and it's one of the most useful sufficient libraries in Python programming. It provides support for large multidimensional array objects and various tools to work with them. Various other libraries like pandas, metapolitable, and scikit-learn are built on top of his amazing library. Features of Numpy. Numpy targets the CPython reference implementation of Python, which is a non-optimizing bytecode interpreter and mathematical algorithms written for this version of Python often run much slower than compiled equivalents due to the absence of compiler optimization. Numpy addresses are the slowness problem partly by providing multidimensional arrays and functions and operators that operate efficiently on array. Using this requires to write some code, mostly inner loops. Python lists versus Numpy arrays. What's the difference between them? Python lists are essentially an array of pointers, each pointing to a location that contains the information related to the elements. This adds a lot of overhead in terms of memory and computation, and most of this information is redundant when all the object is stored in the list or of the same type. To overcome this problem, we use Numpy arrays that contain only homogeneous elements having the same data type. This makes it more efficient at storing and manipulating the array. This difference becomes apparent when the array has a large number of elements, say thousands or millions. Creating a Numpy array. Numpy arrays are very easy to create given the complex problems they solve. To create a very basic Numpy array or int array, you use the np.array method. And as you can see at example, np.array 1 2 3 4, and the output is array 1 2 3 4. Size of Numpy array. You can determine how many values there are in the array using the size of attributes. It just multiplies the number of rows by the number of columns in the array. And there are some basic arithmetic operations on Numpy arrays. On the left side you can see these operations, and on the right side their outcome or result. Thank you everybody for watching. If you have any question you can ask me in comment. Don't forget to subscribe.